Hi, Assalamualaikum. So we will presenting our group assignment MAT210. The title for our group is Path in the Directed Graph. So this is our team member. So the first one is me myself, Muhammad Ashraf. The second one is Muhammad Fakul Arif. The third one is Muhammad Richard Hanudin. And the last one is Afiq Nuraiman. So I will be explaining the directed graph. The directed graph, also called the T-graph, is a graph in which the edge have a direction. This is usually indicated with an arrow on the edge. More formally, if V and W are vertices and each is an ordered pair which is VW, while a directed edge called an arc is an ordered pair VW or WV. So I will be explaining the game background. So firstly, military commander in ancient times need to plan and strategize movement of troops and resources. The concept of directed graph might have been informally applied to represent the flow of force, the direction of attack and the connection between kept military positions. Each edge may represent the safe roads for an army to use or make an ambush or flanking. So there are two applications of the path in the directed graph, which is first Hamiltonian and the second one is Euler. So what is Hamiltonian? A Hamiltonian path or cycle is a concept related to traversing the vertices nodes of a graph exactly once. Okay.
I will be explaining about Hamiltonian path and Hamiltonian cycle. The first one is Hamiltonian path. Hamiltonian path or traceable path is a path that visits each vertex of the graph exactly once. A graph is Hamiltonian connected if every pair of verticals there is Hamiltonian path between the two verticals. Next is the Hamiltonian cycle. A Hamiltonian cycle is a cycle that visits each vertex exactly once, which means that you need to go through all the verticals, but the difference is it needs to return to the first verticals and make the cycle. Next, some connected graph G is Eulerian if there exists a closed trail containing every edge of G. Next, I will be explaining about the differences between Eulerian path and Eulerian cycle. Eulerian path is a trail in a finite graph that visits every edge exactly once, allowing for revisiting verticals. The Eulerian cycle is a trail which start and end at the same graph of vertex. Can do this way by making a graph while hold the pen until meet the origin verticals. Means you draw the line without lifting the pen to do a Eulerian cycle. For the graph, there is two graphs. There is directed graph and undirected graph. For directed graph is a graph which the edge in the graph that link the vertices have a direction. For example, directed graph can be used in map tracking for an airplane. The departure and arrival for the flight can be represented the vertices. Then airways can be represented the edge with direction. Next is undirected graph. Undirected graph is there is no direction in the edge that link the vertices in the graph. For example, a two-way road network that connect a set of cities can be represented by undirected graph. The cities can be represented by vertices, and the graph and the edge represented the two roads that connect the cities.
Then, how can we identify a path in the directed graph? as you can see on the given graph, we can identify as a path in the graph because there is a level of degree for each vertices provided below the graph. And in this situation, all the vertices seems to have all even degree for each vertices. In this case, we decide to use a camber layer as our path in the graph, as it exhibits a unique characteristic which all vertices have an even degree. This implication implies that each point within the theme park connect to an even number of the attraction. The beginning of my journey on the theme park, I start my journey from Hotel to Lego Kingdom and then to Miniland and then City. Next, I continue my journey to landmark and imagination before I went to the last checkpoint, which is my starting point, Lego Hotel. And then I have noticed the path that I was going is Hamiltonian cycle because I start my journey and return back to my starting point while passing every location exactly once. Then we look for a trap journey. As you can see, a trap journey actually looks like the same as mountain, but the difference is he just can find way back to the places that he started. So actually, his journey can be called as Hamiltonian path because he goes through all the places, but he can go back to the original places that he started. And lastly, for Afiq journey, he want to visit all the places in the theme park. However, he don't have any map, so he decided to go each places one by one without even knowing the path that he took. And as you can see in the side, he go to each places until he back to Lego Kingdom again. And after that, he realized that actually his journey can be a Eulerian cycle, which is he go all the way of each places and visit all the places.
Let's go to the question. We have to state the graph. Is it the Eulerian path, Eulerian circuit, or neither? And also, is it the Hamiltonian path, Hamiltonian circuit, or neither? So for the question 1, let's look at the graph first to determine is it exists Eulerian and Hamiltonian. So based on this graph, we can conclude that the neither Eulerian path nor Eulerian circuit because all edges must pass through, but the edges between the B and D did not pass through. Since the edges B and C already passed through, so there are no connection for the edges B and D. For the Hamiltonian, also neither Hamiltonian path nor Hamiltonian circuit because every vertex must pass through ons. For the question 2, we can conclude based on the graph that Eulerian path exists because there are two vertices is odd degree, which is vertex B and vertex D. For example, if we begin from the vertex B, we can go to the vertex C, D, H, F, G, B, A, F, E, and vertex D. But there are no Eulerian circuit because all vertices must even degree. For the Hamiltonian, neither Hamiltonian path nor Hamiltonian circuit because all vertices must pass through exactly ons. For the last question, based on the graph, we can conclude that no Eulerian path but Eulerian circuit exists since all vertices are even degree and all edges passes through ons. For example, we can begin from the vertex A to the vertex D, B, F, C, E, and also last one is a vertex A. For Hamiltonian path and Hamiltonian circuit exist since all vertices passes through. For example, we can start from the vertex B, A, E, C, F, and the last one is the vertex D.
And lastly, the summary. Hamiltonian graph have many applications in different fields, including computer science, mathematics, and pressure research. For example, Hamiltonian circuit can be used to solve the traveling salesman problem, which is the problem of finding the shortest route that visit every city in a given list exactly once. And the Eulerian graph can be used to solve many practical problems like Königsberg bridge problem, They can also be used by man-queries who want to have a word when they don't retrace any their previous step.